I am going to be covering the 7 Habits of Rugged DevOps, which I interviewed the best of the best. And these are the things that they are doing. Think of it as a fitness program, and the muscles that you are building up are those to strengthen application security. And I am so glad Kim went first, although now I'm totally freaked out about any information that's electronic about myself, but it's because security breaches seem to be getting better and not worse. And when we think about application security, the problem is actually systemic. You've got third-party software. Josh already talked about that with the graph. It freaks me out every time I see that graph turn red. I think, oh my goodness, we are exposed in so many different ways with third-party software. We've got latent vulnerabilities, people including known vulnerabilities. We've got unsafe development practices, and I gotta tell you, the developers have no idea. They have no idea that they're unsafe. We are unable to quickly fix problems when they arise. Heartbleed. And we've got misconfigured application supporting systems that are exposing us as well. So, what's the positive news here after Kim scared the willies out of all of us? The traditional life cycle is the one on the top with the really big truck. We used to be delivering software on the 1.5, 2-year cycle since I have myself committed. And security was always at the very end. It was usually manual. It came up with a list of things. There was a bunch of hand waving. Sometimes you were able to fix something very critical. Then everything else was delayed to the next release. And there was very little visibility from either development or operations into what was the problem in the first place. So move on to DevOps. That's the one at the bottom with the little teeny tiny trucks. And what developers are doing is they're breaking up these big monolithic software packages into smaller and smaller digestible pieces in their agile methodologies. Now, as an operations person, this freaks me out because I think chaos will reign. And actually, and after Jez came up, that's actually not true. And part of the reason is because these smaller packages are easier to test. When you did the 1.5, 2-year releases, you couldn't test the interaction with the software to all the other fixes that were going on. And so you ended up releasing something that was actually quite unstable. With these very small targeted releases, they're very easy to test. Now, with DevOps, what you're doing is you're creating the thing on the bottom, and you see lots of feedback loops, you see it's tighter, lots of even between cycles. You're creating a continuous delivery pipeline. I wish I could say it's a single tool. It is not. It is a series of tools that are strung together so that in theory, developers can check in code and it goes all the way out into production. Pretty cool. Now, this is done in conjunction with operations folks so that the right supporting systems are configured correctly at all the right moments. Now, the great thing about this continuous delivery pipeline is, as Damon Edwards mentioned, we are moving left, which means visibility can be given earlier in the life cycle than ever before to those developers, to those operations folks. When the issue arises, they can fix it, move on. But it's all about this visibility and pushing it earlier and earlier. So we at Forrester recommend that in DevOps, folks create what's called an integrated product team. That includes a lot of developers, some ops, enterprise architects, customer experience, and of course, security folks. Now, unfortunately, security is one of those things that usually gets delayed. People start their integrated product team, and they think, oh, we'll do that security later. And it's hard to do. Security, you guys folks have a totally different set of language than we do in operations or development, and so it's yet another cultural divide. But if we're able to band together, and the whole theme of this conference is to assemble the heroes, if we're able to assemble the developers and the operations folks as fighters for security, we can actually better our applications. So habit number 1 is increase the trust and transparency through DevSecOps. This seems pretty obvious, right? We should all be trusting each other. However, usually organizations are set up in silos, and we usually feel like we are at opposing odds. So now, who here are developers? Okay. These stereotypes are holding us back, and the first stereotype is application developers. You guys are seen as the department of anything goes. You're a bunch of yahoos who will get anything done. If you have to skirt security or skirt operations, you will. You are getting your genius out to those customers. I, as an infrastructure and operations person, come from the department of no. We probably have our infrastructure and operations glued together with duct tape and bubble gum, and if you touch it, it will break. And so we end up telling you no. All right, who's security in this room? I hate to tell you, but you're the department of persistent nagging. And it's because we put you at the very end, and all we hear is, you can't do that, you can't do that, you've made a mistake. At the exact wrong time. And so if we think about these stereotypes and we take a step back and we say, okay, what do we all hate? Developers hate unplanned, unscheduled work. They hate it. Ruins their creative flow. Infrastructure and operations, we hate outages. We hate performance glitches. If you're in security, breaches, vulnerabilities, like I said, there's a whole series of language here, intrusions, all of those things, bad. And yet, when you look at this, we're all on the same team. We're just using different language. So part of it is, when you're reaching out to these people, use the right language. If you're talking to an operations person, talk about outages and performance glitches. If you're talking to a developer, say, I can reduce your unplanned, unscheduled work. So if we use common language and understand we're all on the same team, that's one step forward. Simple step, but important. The next one is to understand the probability and the impact of specific risks. I got to tell you, as an infrastructure and operations person, I pretty much ignore security, mostly because I don't want to know. It freaks me out. And I don't know that I can really do anything about it. The trick is, I can. And in fact, as an operations person, the thing that freaks me out most is 47% of the web application servers out there are misconfigured and have unprotected file issues. That's something as an operations person I can fix, but I got to know that it's out there first. So how are you going to increase this knowledge? How are you going to make it part of the conversation? You need to increase the visibility. You have to make it real for developers and for operations people, which can kind of be a trick. My tip here is use real life examples and discuss. Pull up the latest, headline grabbing, and start talking about it. Could this happen to us? What do we have in place that makes it so that we are protected against it? What would we do if we found it? The third habit is to discard detailed security roadmaps in favor of incremental improvements. Now, this is a mind shift change that has to happen. Developers do that change with Agile. They break up things into smaller and smaller pieces. For infrastructure and operations, it freaks us out, but we too have to get in the mindset of releasing smaller changes faster. For security folks, it's a let go of security detailed plans. I have seen 3-year, extremely detailed security plans that were mind-blowing. However, like Kim just said, hackers change. Their methods change, and these 3-year plans do not help us execute or change mid-flight. And so it's a mind shift from, instead of detailed plans, you're going to do these small incremental changes to make application security better overall. And for that, create a vision. And here's an example where you're going to have real-time, actionable measurements so that you can decrease the remediation time for any discovered vulnerabilities. In DevOps, we call this the Plan, Do, Check, Act, where you're taking very small changes. Say you want to insert static analysis right after a developer checks in code. So you're going to go off, you're going to plan. Our plan is to insert static analysis. Do, we're going to go look at tools. We're going to create our rules. We're going to check to make sure it works, that it improves things. We're going to put it in place. And then we're going to do the next thing. Maybe it's tightening our rules. Maybe it's adding another tool. But it's the small incremental changes that you guys are going to make, and advise the team, those of you on security, advise your teams to make to improve application security as a whole. Now remember, this could also vary based on application and what kind of attack surface is exposed, so on and so forth. The habit number 4 is to use the continuous delivery pipeline as your pipeline for security tests. So what can you insert in this continuous delivery pipeline? Pretty much everything. Now, the trick here is these tools take time. And if your team is delivering every hour, they will not appreciate a test that takes a day. So you got to be careful about what you suggest to insert in here and how fast those tools can run. But certainly, pretty much all those tools can fit in. And you see how they're long? They can actually start, many of them, at the developer. The minute they check in their code, checks get run. And some of the best companies in the world doing this, that's exactly what happens. That way, the developer knows immediately what problem it is. Am I using third-party software that has a vulnerability? Am I using unsafe coding practices? Whatever it is, they know immediately, fix it while they're in that headspace of developing that piece of code. Habit 5 is to standardize third-party software and then keep it current. And this is Josh's love. So if you heard him earlier today, there's some pretty scary stats about third-party code. It's everywhere. And the minute you include a third-party piece of code, especially open source, it includes other code, and somehow you have a whole herd of code that gives you exposures. So how do we fix this? And those of you who heard Josh earlier, a lot of this is going to be repeat, but first of all, use new components. Second of all, don't use components that have CVEs. And I know this seems really obvious, but the best way and the easiest way to make that happen is to create a component library. If you make it easy, the developers will come. And even better, make it invisible, and they will come. You want to reduce the number of versions of anything. I talked to a company that had 17 different versions of Tomcat. Well, okay, let's see if we can't reduce that down to some reasonable number. Also, don't forget middleware, your OS, your networking, your database, even your performance management tools all have third-party software that they've included. So you want to make sure that that's safe. And then you use this string of tools to audit and create a software bill of materials so you know exactly what is where. You know where all those 17 versions of Tomcat are installed. So if you find a vulnerability in one of them, you go back and you use the continuous delivery pipeline to quickly replace the issue. If you are able to do that software bill of materials and use the continuous pipeline to do quick fixes, suddenly you're on the offense. Suddenly you are able to quickly fix those problems that come up because you're not going to be able to find everything. The next one is govern with automated audit trails. Now, all of these tools have audit trails. Fantastic. That means you know who did what and where. Possibly attackers, most likely developers, INO folks, even you guys might be out there, security folks might be out there changing things. And it's creating an automatic audit trail for you. That's fantastic. So going back to step 1, we're trying to build trust and transparency, and yet some of the hacks that Kim mentioned were actually insiders. And what we don't want to do is ruin our trust and transparency by also looking over everyone's shoulder for IP issues. So you're going to use this automated audit trail and not ruin the kumbaya moment that we formed with our DevOps practices. And in fact, I put it again on this slide because I think it's so important. So how do we do this audit trail? The first thing you're going to do is you're going to create automatic security alerts in your production environment. You need to understand when an intrusion happens. In 2014, folks were on your network for 205 days on average before folks found out that they had someone in their network. Only 31% of those companies said they found the intrusion themselves. So that's step 1. Beef up those automatic security alerts. And I can tell you, INO folks have no idea. Start with some basics. If you get a lot of network traffic from a single IP, let's start talking, let's flag that. Moving into more and more advanced scenarios, but work with your INO folks to make that happen. The second thing we're going to do is work way back to the very beginning with requirements. And you're going to work with your developers to say, okay, if you guys are doing anything with maybe authentication or authorization, security probably needs to get involved so we can look to see that what you're doing is good. The next thing you're going to do is on 3, there are lots of tools that automatically configure hardware and software. That gives you the ability to remove all logins from people. That means that you can enable only the systems the tools themselves to allocate all the hardware and software. That's fantastic. That means you've got your audit trail, which means that number 4, what you're really looking for is drift. When did someone get in here and do something they weren't supposed to do? Attackers, rogue developers, rogue I&O folks. So then you either change the plan or you've been given an indication that you have an intrusion. The last thing you're going to do is define security-based quality gates. Now, I've put it at the test phase. And the reason I put it at the test phase to start out with is because it absolutely has to be there. But move it earlier and earlier into the life cycle so that the developers immediately know that they failed their security test and therefore can act on it. The last habit is to test preparedness with security games. And this is probably the most fun, and yet the thing that we found the least often, and yet the most experienced teams were really making very good use out of it. Remember in habit 2, trying to create security as a language across the company. Well, this actually does a great job of it as well. Once you have the conversation, now you get to play games. This actually comes from military use where you have a red team that attacks and a blue team that defends. So go back and take that integrated product team, or product teams, and divide them. And so the blue team, they can only defend with what they have in production. That's it. Tools, can you detect an intrusion? When it's happening, that's all they have, is whatever's in production. The red team can use whatever they want. You need to rotate members, make sure you get equal participation. It can happen regularly, for example, every Monday or intermittently. And at the end of it, you're going to make changes to your tools. You're probably going to find that your intrusion detection is lacking. So how do we get better tools in that spot? And you're also going to figure out how fast can we make fixes? Is our continuous delivery pipeline working in our favor? So when you do this red teaming, you're going to really focus on these metrics. How fast were you able to detect the problem? Do you have the right tools and technologies? Probably not. Beef up. The next thing you're going to say is how fast were you at remediating? So once you found a hole, a gap, how fast were you at creating a fix? How fast were the developers? How fast was it able to get through the continuous delivery pipeline into production? And is this an attack that has been tested for, or is this something we need to augment our testing so that it doesn't happen again? And then with that, I will leave you with the 7 habits. And I will be here. Please ask any question about this research or others. Like I said, I interviewed lots of companies to talk about who's doing the best of the best, and these are those. Thanks.